So I'm sharpening up an elmax folder here. This particular one's a zero tolerance one designed by Hindra, and the steel is elmax. Now, elmax is a third generation PM powder metal steel, and it's a very, very, very good steel. Some people have described it as the perfect steel. There's no such thing as the perfect steel. There are steels that are harder, like 390, but really hard, and Rex 121, things like that. They're really hard to sharpen. They're knives which are tougher, like 3V, but they don't offer the same stainless. They will stain. So elmax is stainless, tough, hard, expensive. It's not super difficult to sharpen, but does require a fair bit of work to get it sharp, but then it'll hold its edge for a long period of time. So it's a really good steel. Now, how does it differ from normal steel? Well, it's the third generation PM steel, as I was saying, and so you probably need to know what ordinary steel is. Ordinary steel is iron and carbon. You can add more to it, but essentially, once you've got iron and a certain amount of carbon dissolved into it, you get steel. Now, how you make it is, people don't really make new steel anymore. What they do is they get old steel and they recycle it. So they, for instance, say they're trying to make 1095. They get stuff that's supposed to be 1095. They test it to make sure it is 1095. They grind it up, chuck out any stuff which has got in there which isn't quite 1095. They heat it, then they roll it, sort of mill it, and you get a nice billet of 1095, and then you cut that down into different sizes and shapes, and we buy it and make knives out of it. Same with 01 or any others. Now, the powder metal steels are a bit different. Well, they sort of start off in the same way. They get the steel and they recycle it, or some of the steel is sort of new, they invented it. It's not all made for knives though, it's made for all sorts of uses. But you recycle the steel, you then take that recycled steel, you heat it up. Now they heat it up in a vacuum, so, or in a inert gas like argon or something, so it stays pure and doesn't react with oxygen as the carbon tends to. So you get all that, you get it really, really, really hot, you melt it. Then what you do is you pour it into a second chamber underneath, and as you pour it into that, you direct another jet of gas into it. Very fine, very hard. And what happens is the metal powders, it goes like, well, powder, it goes like snowflake. It falls down, separates out, and goes into little bits of dust, essentially, really small, fine powder, collects down the bottom. Now, when they get enough of it, they then heat it up, put pressure on it, roll it into a bar and mill it, and you get your steel how you wanted it. But the interesting thing about this process is that all the little carbides in there, supposedly, get either broken up or they get evenly distributed. Now, carbides are little hard things, much harder than normal steel, and so they lend the blade a good amount of strength, but they also create fracture points. So when you hit something hard with your blade, the knife will fracture on a carbide if it's on the edge. That fracture will continue through the carbide, and then it goes through the steel, finds another carbide, cracks that, finds another one, cracks that, and eventually comes out and you get a little chip. How you actually, why it does that, just the way it works. You need to be a metallurgist to really understand that. But essentially what happens is the carbides, being much harder than normal steel, are the first things that crack, and they find other carbides, they transfer the energy of the crack to those other carbides, and you get a chip, and that falls out. Now the PM steels, theoretically, especially the third generation ones, the carbides are broken up into really, really small particles and are really evenly distributed, the ones that aren't sort of broken up, so that in your blade at the end of the day you get steel which doesn't chip, hopefully, or not as much. You get a much more even distribution of carbides, and you get a very pure, very good steel. Now elmax is one of them. There are a few others. 390 is another one. There's playing around S30, S35, lots of different sorts for lots of different companies. elmax is one I'm particularly interested in, and I don't know why. I just like the idea of that particular one. It's got 1.7% carbon, it's got 18% chromium. It seems to me that it's got 3% vanadium, and then it's got a little bit of manganese, a little bit of phosphorus, a little bit of silicon, a few other bits and bobs, and of course iron. It seems to me that it's a good combination. It's stainless, not stain proof obviously, but stainless, so you can use your knife without it needing as much maintenance. Still needs maintenance. Every knife should be maintained properly. It's hard, so once it's got an edge, and I'm giving this one an edge, an 18-degree edge in fact, what I'm working on here is, and it takes the edge for a long time. It'll hold the edge quite well. It will chip if you abuse it, but it's a good steel and should hold it fairly well. Now, with this particular one, I'm putting an 18-degree edge on it, as I alluded to before. I started off with diamonds and reset the edge. Cat's going mad in the background. And then I'm working my way through a whole pile of stones that came with this TS Prof. So this little silicon carbide stones, or aluminium oxide I think they are actually. And then I'm going to switch to Japanese water stones. At the moment I've got a 1000 grit going. I started on 120, well I started on diamond 200 micron, and then 160 micron, then 120 grit, 220, 400, 600, and now I am going on 1000. Then I will remeasure it, make sure I'm still on 18 degrees because the stone thickness will change, and then I'll work 2000, 4000, 8000, and then I'll strop it, and then we will have a beautiful elmax blade with a finely polished edge. And being elmax, it means it won't rust, should hold its edge for a long time, and be a good all-round knife. Now I'm also, shortly, hopefully, going to look at a forge that might be, or a kiln that might be capable of allowing me to do my own elmax. And if I can do elmax, I can do a lot of other steels as well. It's not limited to elmax. I need to sort of be able to do, I say 1080 degrees, ideally up to 1150 depending on the recipe you read. So I'll just have a look at that tomorrow. It's a second-hand one a friend's got, doesn't want it. Yeah, so that's elmax. Good steel. Cheers guys.